Okay, now that we learn about how you can manipulate your brushes and the geometry by moving things around, rotating them, scaling, and so forth, let's get a little bit more to what we have in terms of creating BSP brushes and geometry in your UDK. There are several brush primitives that UDK gives you that you can use to create your level, and or essentially what becomes the basic properties and the basic geometry of your level. There are a couple of things that you need to think about and be kind of mindful when you're creating your geometry. One of them is that it is very important for you to understand that BSP brushes create BSP cuts. What that means is that whenever you add a brush and it's a solid brush, you are essentially making or asking your level to think of a binary space partitioning cut in your geometry, in your level. And if you have too many of those, that complicates the way that your eventually your gameplay would turn out to be as far as its complexity. With that in mind, let's look at the kinds of brushes that you have. And I would like to point out to you from this point on the things that you see in terms of the Unreal Tournament editor from the book are the way that UT3 was set up. So there are quite a few changes, at least as in relation to how the things are organized in different menus and toolbars and things from UT3, Unreal Tournament 3 editor, and UDK. And if you want to think about it, UDK makes things a lot more intuitive and a lot more user friendly and easier to manipulate and work with compared to UT3. So what you see in your books in terms of your tutorials is how UT3 sets the things up. So there may be things that have been moved around, some things may not exist anymore, some things may be different, and I will put the further readings from UDK Network, Unreal Developers Network, tutorials and materials essentially that complements what you have in the book. And the book is basically to give you pointers to how to do things, but specifics of the things, at this point, I would believe that you should be feeling comfortable working within the UDK. So finding specifics of the things should not be difficult for you. And so the more you work with UDK, the more you get used to the stuff that are done within UDK editors. But as I said, be mindful of the differences between UDK and UT3. So there are some things in UT3, I will point them out, as I said, and the differences out. But when you see something in UT3 from the book that doesn't exist in UDK or maybe moves around, you can use Unreal Developers Network to find them. But you should be able to figure things out as we just basically work more with UDK. But that being said, there are several brushes in UDK. So we start with the basic primitive. It's called the cube brush. If you right click on it, you will see that you will have a cube brush. It doesn't necessarily need to be cubic, meaning that X and Y and Z being equal sizes. We can have different sizes on X, Y, and Z. We can have the wall thickness. Here is 16 units, and that can be used when you're creating a hollow cube. So here you have a hollow cube. Let me zoom in, and you can see that the wall thickness for this hollow cube is 16 units apart. And so you can increase the thickness by moving it more and more. And so the more thickness you have, the thicker the wall will be, and vice versa. And if you click on tessellated, the cube that you create or the geometry that you create will be tessellated, meaning that the faces of your cube will be based by breaking them down into triangular forms or triangles. And so if I click on tessellated, then the geometry that you see here is going to be, or the brush is going to be broken down into triangles. Next brush is your cone, and if you right click on the cone, you would see that the cone brush basically creates a cone, and you can change its Z value, which is basically the height of the cone. You can have the cap of the Z different than what you have on the Z axis. You can have the outer radius of your cone and the inner radius of your cone changed, and of course the cap and the inner radius are used when you are creating a hollow cube. So you can the cap Z designs or creates the inner um, top of your cone. The Z is basically modifies the outer top of the cone, and the inner and outer radius are used for creating the inner and outer areas of the cone or the base of the cone. And remember, the inner radius and the cap are used when only the hollow option is open. If the hollow option is unchecked, then you will have your cone essentially just using the Z and the outer radius. The staircase looks like a staircase, of course, and basically a curved staircase. You can change the inner radius, you can change the step sizes, the step width, and so forth, and you can make your basically staircase to go clockwise or counterclockwise, and you can increase the number of steps that you have, for example, to 16 steps, and you can change the angle. For example, to 45 degrees, it creates a 45-degree staircase. 180 degrees essentially creates a 180-degree staircase, as you see here. You can have a cylinder brush. Again, you have a Z radius, outer and inner radius for hollow option, and you can have your you can change the size of your cylinder and so forth, and when you're satisfied with the value, you can create your radius. Linear staircase, again, is a linear staircase. There's a difference between sheet object and brush, cube brush. If you click on the sheet brush, you'll see that you can change the size of the sheet. You can have multiple segments in X and Y. So here X and Y are one segments. You make it, for example, 128 by 128. Then you would have a kind of grid pattern as you see here, and you can have your axis either horizontal on x-axis and y-axis depending on where you want your the sheet to be created. Notice that there's the sheet material or the sheet brush that you create, and if you create an additive brush, for example, just as I have here, so the sheet brush becomes it's basically a brush that does not interact and block objects, and usually what you will use this sheet brush for is for creating surfaces of fluids. For example, if you have a pool and you want to put just the pool surface, like the water surface on the pool, you put a sheet and then you apply a water material on top of it, and that would look like the water surface. Okay, and you can have the sphere brush. Sphere brush is basically a tetrahedron, and the tetrahedron is basically you can extrapolate it, or basically approximate it by a number of iterations. And so the more iterations you have, the closer your shape looks like to a sphere, and of course the complexity of your tetrahedron will grow. So it's always a trade-off between the accuracy of your tetrahedron and your sphere with the complexity of the object that you create. And there's the cards primitive. The cards primitive look like a bunch of sheets that intersect with each other. Here, if you create one, it'll create two sheets, for example, and here's how it looks like. And what you usually use these cards primitives is for creating illusions, like, for example, fire or tree branches and things of that nature. So you create a bunch of these sheets, basically, or cards, and place them, and then you can apply materials to them. And from afar, they look like they are basically made of, or they are fire, or they're a tree and stuff like that. Now, Unreal Development Kit UDK has improved its designing materials and tools. And so, for example, for tree materials and creating trees, you really don't need to use these card primitives. You can actually go ahead and use a tree builder of Unreal and create trees and apply different properties on the trees and so forth. But we will not go into those details now, and toward the end of the semester we might work with those advanced tools. Alright, now that you learned a little bit about the primitives that you have, you notice that you can click on any of these primitives, as I showed you earlier. Right click on the primitive, the window opens up, you can change the property of the primitive, and then what we have seen so far is that you can add constructive solid geometry using those primitives by clicking on add solid geometry or subtract solid geometry. Add solid geometry would add an object or your constructive geometry or the brush, and subtract would basically take that brush away. Or that piece of geometry apart. So here is just to show you how we can do that. I have the red builder brush, which is a box or a cube. I click on add geometry, and as you see here, a blue wireframe is added to my geometry, and in the viewport, in the perspective viewport, you can see the geometry build. Just rotate around, and here is my geometry. Okay, and if I let's say that if I right click on my cylinder, make a smaller cylinder, and just rotate this cylinder, and if I wanted to create a little hole in this solid geometry that I've created, you could click on subtract geometry, and the subtractive geometry, as you see here, is going to be the brown wireframe in your viewport, your orthogonal viewports, and you can see that a piece of geometry has been subtracted from the solid geometry that you had before. You can have two other kinds of geometry or two other kinds of operations that you could use to create more complex options or objects. Let's suppose that I want to create a small tetrahedron here. That would be my sphere, and if I wanted to take a piece of this geometry out in a Boolean way, and actually let's put this on the top viewport. Okay, you can use this complex Boolean operations, intersect operation or de-intersect operation. If you wanted to just keep the or make the new brush to be the part of the brush that belongs to the geometry, or basically intersection of the already made geometry and your builder brush, you can click on intersect. So an intersect would create a brush that looks like this. So it's basically the intersect of the builder brush and the piece of geometry that I had so far. And then if you add that part as a additive geometry, it basically would create a piece of the pie, as you see here. If you wanted, on the other hand, to have the other part of your builder brush, basically, or the difference between the builder brush and the geometry, you could click on the de-intersect option, and this will create a de-intersect brush. And here's how your brush would look like. on your viewport. And then you can add an additive geometry. So the geometry that I created here, I showed you how you can create additive and subtractive geometry. These geometry that we have done so far by adding and subtracting geometry, the solid geometry is basically a solid brush, meaning that it will block both players and bullets in your level. They can also be either subtractive or additive geometry, and what they do in your level or in the world geometry is that they create BSP cuts. What that means is that whenever you add a solid geometry like what we have here, when you add it or subtract it by clicking on add geometry or subtract geometry, your world will be cut in two parts, this brush and everything else. And so if you keep adding these BSP cuts in your level becomes complex, and these BSP cuts are used for lighting purposes, for AI and pathfinding purposes, and for creating your geometry basically and rendering it in your level on your graphics card. So if you keep making this complex cuts, then at some point your level will suffer from some performance hits. There are different kinds of brushes that you can add to your geometry. Aside from a solid brush, you can add semi-solid brushes or non-solid brushes. As I said, the semi-solid and non-solid brushes have to be additive. Both of these semi-solid and non-solid brushes do not add any BSP cuts in your geometry, and the difference is that semi-solid brushes don't add BSP cuts in your geometry, but they block players and bullets, whereas non-solid brushes neither add BSP cuts to your geometry, nor do they block the players and bullets. So basically they look like you can use a geometry like a cylinder or a sphere or a box and make it like a sheet. Basically, it does not interact with your objects. So here, just to show you an example, let's go ahead in this level and let's add three kinds of geometry here. So I have this solid brush here, and I can add a additive geometry, and then I go ahead and I click on special brush, and then from the special brush I add a semi-solid geometry, and then go ahead and from the special brush I add a non-solid geometry. So if you look at the wireframes of these objects in the viewport, one of your orthogonal viewports, solid brushes and additive brushes render in a blue wireframe. Semi-solid brushes render in a kind of reddish or dark brownish wireframe, and non-solid brushes render in a green wireframe. Okay, and let's let's build this geometry and build the lighting and play this level. Okay, so here the three brushes are solid brush to the right, semi-solid in the middle, and non-solid to the left. So your player can go through non-solid brushes, as you see here. The player will not be able to pass semi-solid brushes, but semi-solid brushes do not add BSP cuts to your geometry, and the player cannot go through solid brushes, but they do add BSP cuts to your geometry. So if you keep adding all these brushes as solid brushes, you will add BSP cuts. Now, why do we add solid or non-solid brushes? For the solid brushes, you add them when, for example, the brush is an entire room in itself. So you have inside the room, you have a different partition than you have on the outside of the room. Whereas if you are creating a temple, for example, for your mini assignment, the columns of the table or the temple or the walls of the temple do not have their own BSP cuts, and they're not supposed to create BSP cuts or create new areas, so to speak, in your level. You can use semi-solid brushes for those areas. Let's say that on between two columns you wanted to create a kind of banner or a little or put a piece of cloth between the two. You could use a non-solid brush, and then you could apply a cloth material on top of it. And so your players will be able to go through it because it's just a piece of cloth, but you want to just give some sort of geometry to your level. So these are the differences that you have. Now let me save the level in a deathmatch, and I can show you from behind view of the player how the solid, semi-solid, and non-solid brushes look like. Okay, so here I have the player. So the player, as you see, cannot go through solid brush. It cannot go through semi-solid brush, but it goes through a non-solid brush, as you see here. And so do the bullets, whereas solid and semi-solid block the bullets. Okay, semi-solid, solid, and non-solid.